Oh,
Alright, go ahead.
Wait, hold on.
Alright, Jamal's gonna go.
What I'm doing?
We want you to take a look through the spectroscope, little eye socket,
What's up with the button?
and you're trying to see the line spectra right here. There's really two clear lines, and there are two that are a little faint.
So I gotta, where's the line?
Look through there, and then you're gonna press the button. You should see these wavelengths, nanometers.
I see one.
4. Yeah.
Which two isotopes are one of them? Is it that one?
Number 4 is B.
Yeah, I said B.
Good job. And number 5. Zane?
Which is the number of neutrons in 80/35 VR? Is it C?
What number are you on?
We are on number 5, right?
Yeah, 5 is B. Sorry, I lost track. And number 6. How about Zane?
The atomic mass of an element is the C, weighted average of the masses of isotopes of the element.
Very good. And how about number 7? Let's go with Jamal. You got 7?
I said B.
Can you read it for us?
In atoms there is 23 protons, 29 neutrons. Which is the correct chemical substance? I said B.
Yeah, 7 is A. Nice try. Number 8. All right, Chris. Um, 8 is B. Number 9. Good job, Chris.
No, no,
We got 9. How about Minnie? Okay. How about Simon? Number 9.
A.
Can you read it for us?
Which symbol is correct for this atom? Well, for that question, I got A.
Yeah, C is correct. So Ernest Rutherford's model was considered to be the planetary model, and the dilemma of the atom is what proved the planetary model incorrect. And the big point is right here. The charged particles moving in a curved path. You can see here we've got a curve. This would be the planetary model, like this is the sun and the earth is rotating and around. Everybody clear? That's what Ernest Rutherford thought in the Goldfoil experiment. So they studied this, and they learned that electrons like to move in waveform. Why do they like to move in waveform? Because they are small. And that's kind of what distinguishes energy from matter. So in science, we study that energy is a little bit different than matter, behaves a little different. Its mass is a lot smaller, tends to move in waves. Whereas mass, or matter, that we study, like the proton, tends to move in direct paths. Right? Now, we're still kind of studying the alpha particle a little bit. That is the helium ion, whether it moves in waves or direct paths. Some people say it moves in waves. So the predominant mode of travel is wave across long distances. And why is that? It allows you to bounce off of things. Think of it like, kind of like a spring. A wave is like a spring. So if a spring is going along, right, and it hits something, it's going to be easier to bounce off of it or move around it. Whereas if you're just traveling a direct path, you're just going to want to stop where you're going. So the wave provides a lot more spring. You can see it right now with the light bouncing off all over the room. Light wouldn't do that if it moved in direct paths. It would just stop, right? And you wouldn't get any, you wouldn't see blue. Because remember, blue is coming back to us on your shirt, like that paper behind you. All the light wavelengths, except blue, are being absorbed. Make sense? Yeah.
I don't know what I'm supposed to be looking for.
You're going to look to the right here, and when you press the light, you see it light up.
I see like one color.
Do you see a line?
I see like the 400, 500, 600, 700.
Okay. So push the button and then let it go, and see if you see a line like you see.
Oh, okay, yeah.
See the line?
I see. Yes.
See the light? See the light? $22 is B. Good job, Deshaun. And 23. All right, Chris.
An atom has an atomic number of 76. The number of protons and electrons in a neutral atom of the element are D.
23 is D. 24. How about rain? 24.
What type of radiation is likely to occur when the ratio of protons to neutrons is below their stability? I chose C.
25 is C.
Oh, wait. We're on 25 or?
We're on 24. 24 is A. I'm sorry. I was looking at the wrong one. So 24 is A. 25 is C. Any question on 25? So 25 reads, the atomic mass of an element depends upon the, and that would be C, the mass and relative abundance of each isotope of that element. All right, 26. Anybody got 26? Chris?
Which of the following sets of singular isotope of the same dosage is A?
Excellent. 27. Alu?
What particle is emitted in alpha radiation? D.
D is correct. And how about Daniel?
In which of the following sets is a symbol of the element, the number of protons and the number of electrons given correct in D?
Okay, D is correct. The last one is D. Does anybody have any question on any of these problems so we can like go over in class and reinforce this concept? You're going to see some of these probably at least 2/3 again on your final. Because remember, the final is comprehensive. So I'll change these questions mathematically. I could, change the values of the numbers, but keep the actual question the same. So if you have a question about one of them, I can work on the board. I'll do that. Any questions? Simon, any question?
40% of 14C as order actually found in
Test her.
If the half-life period of 14C is 5,770 years, find the number of years elapsed. Example A, 7.63 times 10 to the third.
Okay. And 14? Or on 11? Oh, sorry. Yeah, 10 was A. Go ahead, number 11. All right, Hannah.
A neutron breaks down into a form of C, a proton, and an atom.
Correct. 12. Heather, you have 12?
Yeah. How does a positron differ from an electron? And I said B, a positron has a charge opposite that of an electron.
Right, these are extra credit points for every one you get correct, so it can improve your grade. And 13. All right.
A chemical composition of two or more electrons joined together in fixed proportions is known as a compound.
Okay, 14. All right, Hannah.
If E is a symbol of an element, which two common symbols represents isotopes in the same element? And I said C, 1 and 4.
Symbol for this atom.
So what's your response? You don't know? All right, raise your hand. Hold on, Josh. You got two seconds. No, Naomi. A is correct. All right, number 8, Cameron.
What is the relative mass of an electron? B.
That is correct. You said B. Number 9, Rosebud.
Number 9, I got that wrong.
Read it for us.
I believe in you.
Wow. I got that wrong. Okay. Which is the correct symbol for this atom? I said B, but that's wrong. So, but I have been informed that it's C.
Right, if you have a question at the end of reviewing this, I'll address it. Number 10. All right, it's the answer C. She said C, that is correct. All right, Josh.
A sample of wood from the remains of a ship was found to contain 40% of 14C as of ordinary wood found now. The half-life period of 14C is 5,707 years. Find the number of years. I said A.
And number 11. All right, Zadie.
A neutron breaks down to form C, a proton or an electron.
And 12. Let's go with Christian.
How does a positron differ from an electron? I got it wrong. But I chose C.
All right, the correct response is B. Number 13. They have a different charge. How about Annette?
A chemical composition of 2 or more. Okay. Are you okay? A chemical composition of 2 or more different.
He's taking you over.
I'm gonna read you. No, a chemical composition of 2 or more different elements joined together is known as a compound.
That is correct. And 14. All right, Gabe.
You're struggling so hard.
If E is the symbol for an element, which two of the following symbols represent isotopes of the same element? I put letter C.
Does anybody have any question on any of those? We'll go over. Now you'll see some of those again on the final, which will be in December. Right. So we're moving on in the textbook into chapter 5. Right. Talking about the electrons and their orbitals. And if you go back to Ernest Rutherford, right? He was the one that came up with the planetary model of the atom. Y'all remember the planetary model? Looks like this. You got like a nucleus. You got electrons that move around it. Does that sound familiar? Now, this model was disproven, and it was disproven by J.J. Thomson's son. And what did J.J. Thomson's son discover? J.J. Thomson's son discovered that the electron is an energy wave. The electron's an energy wave. So if the electron's an energy wave, then you're not going to have basically a planetary model where electrons are moving around like planets, like the Earth moves around the sun. That's the planetary model. Things that have mass tend to move in direct paths. So when we talk about matter, like I'm moving in a direct path right now, across the room, I'm not doing the Jar Jar thing and in a wave, right? It'd be kind of hard to watch things in a wave form, right? So I'm not moving in a wave form, I'm moving on a direct path, and that's what matter tends to do. So energy tends to move in wave form, and George Thomson, J.J. Thomson's son, discovered that electrons have wave energy.
You disagree with his father?
No, his father didn't know, right? Now the big problem, that is with the dilemma of the atom with J.J. Thomson and with the plum pudding model, and then Rutherford, the big dilemma there with his planetary model was that charged particles moving in a curved path lose energy. Like if you're running around a track, right, when do you tend to slow down? When you get to the curves. Now if you've run before, you understand that, because you got to throw your arm in because your body wants to go forward. So you can throw your arm in so you're turning, but it's still going to slow you down a little bit as you pull your arm in, right? Now there's some people that pull their arm in and they pull their other arm and they kind of run like a dishwasher back and forth, and they're kind of doing the wave this way. That's why they're slow. So charged particles moving in a curved path lose energy. Now what the question is, what keeps the atom from collapsing? Ethan? Alex? What keeps the atom from collapsing? Rachel? What keeps the atom from collapsing? Repulsion. So the electrons repel each other in the layers, right? Now they can collapse. Atoms can collapse, and what do they form when they collapse? Neutron stars, right? So if there's enough pressure, they can collapse in on themselves. It takes a lot, though, to overcome those repulsion forces. Remember, the electron is attracted to the nucleus, right? So stable things can be formed given the right environment. And that's what keeps them from collapsing, is the repulsive and attractive forces. It's kind of like a balance going on there, which is pretty cool. 7 is A. Number 8. All right, Carlos.
What's the relative mass for an electron?
Number 9. How about Brendan? You read for us?
What is the correct symbol for this atom? I put B.
Number 9 is C. Number 10. All right, Diana.
A sample wood from the reagent ship was found to contain 40.0% of vortex gases. Ordinary wood found now. If the half-life period of vortex is 5,770 years, find the number of years elapsed.
A is correct. Number 11. Anybody? All right, Diana.
A neutron breaks down to form after C.
C is correct. Gabriel.
How does a positron differ from an electron?
Nice job. And 13. So you want to read these aloud because you'll see them again on the final. That's why we're reviewing this. These questions, the only ones that are mathematical will change. The other ones I can change the order, obviously. But you'll see the same concept again on the final. So you'll score higher, hopefully, by reviewing this. All right, who's got number 13? Carlos?
Chemical composition of two or more different elements joined together in
number 10. Josh?
A sample of wood from the remains of a ship was found to contain 40.0% of 14C. As of the ordinary wood found now, the half-life period of 14C is 5,770 years. Find the number of years elapsed. And I got a 760.
Good job. All right, Rachel. Number 11. No, we're going over. You can read it, though. Can you read it for us? And you can't have your hoodie up like that. It's the rules. Goodall's going to come after you.
A neutron breaks down to form.
I'll put C.
C is correct. And number 12. All right, Giovanni.
Okay, what is it? How does a positron differ from an electron?
Yeah.
And I said B, positron has a charge opposite that of an electron.
And 13. All right, Trey.
A chemical composition of two or more different elements joined together in fixed proportions is known as A.
Good. And 14. Now, some of these same questions will be on the final. Like question number 1, even though we reviewed it and it's been like 6 weeks since we talked about it, people got that wrong. So I try to give, questions you're going to see again on the final so that, qualitative concepts are sometimes easily forgotten. All right, 14. How about Rebecca?
If E is the symbol for an element, which two of the following symbols represent isotopes in the
Once again, George, he described the wave nature of the electron. However, we do not know what causes the wave nature of the electron. That is, how it forms, how it stays as a wave. We don't know what drives this. We don't know if it's the last electron, the first electron. How are they all working together to form like one wave? We know that the frequency that determines the wave, I guess you would say length, whether it's going to be a large wave or a small wave, that is the frequency. I can show you that right now. So if you look on the overhead, you'll see that right there, when you have 4 cycles a second, you see how the wavelength is different? This is a longer wavelength. These are shorter wavelengths the more cycles you have per second. 16 cycles a second would be 16 hertz. So when you're looking at like frequencies and they talk to you about hertz, like if you got 30 hertz or 500 hertz, that would be 500 waves in a second, right? So we know that how many waves a second can determine, the wavelength, right? What we don't understand is how the electrons know to change their wavelength like this. That's the question. How are they doing that? That's the unknown. Today we're going to examine hydrogen spectrum and helium spectrum. Each element has a designated spectrum. So Henry Moseley, he didn't look at the spectrum, the electromagnetic spectrum, he looked at the X-rays. And the X-rays tend to be a little bit more precise. Why are the X-rays more precise than the electromagnetic spectrum? Here's indium, lithium, mercury. So why would X-rays be more precise compared to the electromagnetic spectrum? Might know? Well, with this you have to use the human eye, right? So we're using the human eye to examine this. And some of these colors, like the purples here, are very hard to see. So you're going to see that in a minute. It's very hard to identify them with the human eye. The nice thing about X-rays, you can use a machine to do that. It will tell you, a readout, which will be much better than a spectrum like this. Right. So X-rays were used, and they're still used today to identify elements on like Mars and other planets. X-rays are the preferred method. Also, when you start pushing electrons down into the first and second energy level, you tend not to get visible light that comes out. You tend to get like gamma rays, X-rays. So X-rays are really going to help you understand in detail what's going on with these larger elements. Make sense? So good. Number 7, Minerva, read number 7 for us.
Okay. An atom has 23 protons and 29
C.
neutrons. Which is the correct symbol for this atom?
The answer is A. Number 8. All right, Miles. Number 8 is B. Number 9, Liam.
Which is the correct symbol for this atom? Let's put C.
Number 9 is C. Number 10, let's go with Darian. Read 10 for us.
A sample of wood from the remains of the ship was found to heighten 40% of it.
38. How about Christian? Yeah, 38C. Good job. And 39. All right, Harrison.
Which scientists described the existence of the neutron output A?
40. Austin.
Which scientists developed the model of the atom shown? Put C.
And 41. Now, everyone you get correct as we're going over these, this is like a bell work point, which goes into the bell work category. So most people now are already over 16, but if you want to get more extra credit, I'm trying to encourage you to read these questions and answer them. All right, Carlos.
The equation that the blank K of radioactive particle would be focused on the ratio of new nitrogen 14 atoms and
And 42. TT.
What is the average atomic mass of an element A?
And 43. All right, so with helium, you should be able to see at least 3 or 4 compared to hydrogen's 2. The ones in this side are a lot more faint. You almost need to have a dark room to see them. So check them out, see if you can take a look at helium.